A number line looks rather innocent. 0 occupies the middle of the frame. Positive integers stretch to the right. Negative integers stretch to the left. But when we look at a number line closely, the space between integers is very crowded. In fact, we could say that the space between integers is infinitely crowded. Let us take two integers, 2 and 3. How many numbers occupy the space between 2 and 3? We could pick two numbers, 2.7 and 2.8. But then we ask the question, how many numbers occupy the space between 2.7 and 2.8? We could pick two other numbers, 2.75 and 2.76. But then we have to ask the question, how many numbers occupy the space between 2.75 and 2.76? We could pick two other numbers, 2.751 and 2.752. And so the march of numbers goes ad infinitum. We can construct this task, and it is like the task of Sisyphus. Sisyphus was a king who was condemned to roll a large rock up a hill in Hades. The tragedy was when the rock got to the top of the hill, it slid back, and Sisyphus had to start the task all over again. Trying to find the answer to the question how many numbers occupy the space between 2 and 3 is a Sisyphean task. It'll go on forever. We can do this incessantly. We can do this perpetually and never get to the end of the task. Another interesting question about the number line is, what kind of numbers occupy the space between 2 and 3? Let me talk about rational numbers. A rational number is a number that can be expressed as a fraction of two integers, where the denominator and the numerator are integers, and the denominator does not equal 0. Many examples of rational numbers. Here are a few. The number 0.7 is a rational number because it can be expressed as a fraction 7 over 10. The number 1.3 is a rational number because it can be expressed as the fraction 13 over 10. Square root of 9, which is reducible to the integer 3, is a rational number because it can be expressed as a fraction 3 over 1. Even the recurring decimal 0.33 is a rational number because it in fact is a fraction 1 over 3. The fact that there are rational numbers implies that there must be irrational numbers, and in fact there are. An irrational number by definition cannot be expressed as a fraction of two integers. Examples: the square root of 2, which is not reducible, the square root of 3, which is not reducible, and the most famous example of an irrational number is the number pi. So as we have seen, the number line is a very crowded space, and it is made up of rational and irrational numbers. Now, there is another type of number that does not even belong in the number line, and these are imaginary numbers. Take the square root of -1, for example. There is no number, there is no real number, which multiplied by itself will give us -1. So there is no real solution to the square root of -1, and we call this an imaginary number. So the number line is a fascinating line, very crowded, infinitely crowded. And then outside the scheme of the number line, we have imaginary numbers. Happy numbering!